Welcome back. This is a recording for lesson 5.6, Ratios and Rates. This lesson is part of Math 020 pre-algebra course taught at St. Louis Community College. The recording is completed by Dr. Victoria Shearing. In this lesson, we are going to talk about how to find and write ratios, how to find and write rates, and how to differentiate between rates, unit rates, and unit price. So let's go ahead and get started. We're going to start with the formal definition of the ratios. A ratio compares two numbers or two quantities that are measured with the same unit. The ratio of A to B is written as using the words A to B. It could also be written as a fraction A over B, or using a dot notation A double dots B. So could be written using words, could be expressed using a fraction, or could be expressed using the dot notation. So all three notations are ratio notation. So our first objective is to practice how to write each ratio as a fraction. And of course, as soon as we do the fractions, we need to reduce them to lowest terms. So we have 10 pounds to 14 pounds. I'm going to use a fraction notation. So I'm going to put 10 over 14. All right, and then just double check that they can be reduced further. 2 goes into 10 and 14. So let's reduce it by 2 to get 5 over 7. And then 5 and 7 are both prime numbers, so we reduced it to lowest terms. Okay. If you need a refresher on how to reduce fractions, you should look through Unit 4 videos. We covered it there. Okay. So the next one is you have 14 ounces to 7 ounces. So as they come in the problem, grab the first number and put it in your numerator, 14 ounces to 7 ounces. All right, and then we can reduce 14. 7 goes into 14 twice. So as a ratio, it's going to be 2 to 1 if we are keeping it as a fraction. Okay, so this is not, we're not going to rewrite that as a whole number because we need to keep it as a ratio, 2 to 1. So 3 cups to 9 cups, same process. 3 cups, 9 cups, reduce it by 3, 1 over 3. So that is your lowest terms fraction. And then we have 1850 to 350. So let's see. We are going to start with the 18.5. And then we're going to do 3.5. Well, let's double check that 3.5 does go into 18.5. I have a feeling that it does. So 18.5 divided by 3.5, and not quite. So we can reduce it by, let's see what we can reduce it by. Let's go ahead and get rid of the decimal. Let's clear the decimals. So we're multiplying everything by 10. So we would have 185 over 35. Because before we can reduce, let's go ahead and get rid of the decimals. Okay, if I multiply both sides, like top and bottom, by 10, I am going to, and now it's easier for me to reduce this fraction. So I know that 5 goes into 185 and 35. So it goes 7 times into 35. And then 5 goes into 185, 37 times. All right, so 1850 to 350, the ratio is 37 to 7. Okay, so we also use ratio to solve problems. That will be we will be working on it in our next lesson, but we're going to practice setting up our ratios so we can be ready for the next chapter. So second example, for a recent year, 250 million people were covered by health insurance in the United States and 45 million were not covered. In part A, we need to write a ratio of the number of insured people to the number of uninsured people. Okay, so 250 is your insurance here, and then 45 million, no insurance. All right, okay, so ratio of insured to the uninsured would be 250 million to 45 million. All right, so all this is in millions. So let's go ahead and reduce that. 250 to 45. So 5 goes into 250 and 5 goes into 45. So 50 times here and 9 times here. All right, 50 to 9. Okay, you can so that is your ratio for part A. Okay. Write a ratio of the number of uninsured people to the number of insured people. So all you're doing is flipping it up. So uninsured were 45 million. And then you have 250 million. So everything is in million. And then we can reduce it again. 5 goes into 45 and 250, 9, 250. And then we can drop the million. So for every 9 uninsured people, we're 50 insured people. That's how we can say it. Okay, so that's our second part B. And then part C, write a ratio of the number of uninsured people to the total number of people. All right, so they did not give us the total number of people, but they did give us the 250 insured and 45 not covered. So together, that number is 295 million, 295 million. So total number of people, sorry, to write it, not to draw. Total number of people would be 250 million plus 45 million equals 295 million. Okay, so now that we have an uninsured, we're 45. So we do 45 over 295. So this is all in millions. And now that we're going to reduce the fraction, we can drop the millions. So the 5 goes into 295, 59 times, and 5 goes into 45, still 9 times. 9 and 2 and 59, not 259. 9 and 59. And that is our answer for that one in reduced terms. So just remember, anytime you work with fractions, they need to be reduced to the lowest terms. All right, so let's double check. I do believe this is, now we have a couple of more. Okay, so let's keep working on a couple of more word problems that we have. In these sections, and especially in Unit 6, we will encounter mostly word problems. So we'll build our stamina for that. We'll practice using the word problems, and by the time we're done with Unit 6, you will be fine. So example number 3. At a school sporting event, the concession stand sold 450 bottles of water, 200 cans of soda, and 125 bottles of iced tea. Write a ratio of the number of bottles of water sold to the number of cans of soda. Okay. So bottles of water to cans of soda. So let's go ahead and grab those two numbers. We have 450 bottles of water. And then soda was 200. That's our soda. So that means 450 to 200. So let's go ahead and reduce that by 50. So we're going to have 9 to 4. And that is it. That is in the lowest terms. So the next part is asking us to write a ratio of number of bottles of iced tea sold to the total number of drinks sold. So here we're going to need to do a little bit of work because they did not give us the total number of drinks sold. We don't have that number. So total number of drinks sold. So let's go ahead and add them together. So we have the 450 for water, we have 200 for soda, and we have 125 for iced tea. So we have 650, 775. All right, so 775 total drinks were sold. Now, bottles of iced tea. So we sold 125 bottles of iced tea to 775 total. So that means the ratio is 125 to 775. And now we can reduce it. Let's try the 25 first. Yeah. So 125 goes into 125 5 times, and 31 into 775. So 5, 31, smaller numbers, we can see that there's nothing in common between them, and this is our answer. So that's, in a nutshell, the ratios. The big thing about what we learned about the ratios is that we can use 3 types of notations. We can use the 2-word, we can use the fraction, which is most commonly used, and we can use the dot notation. Okay. And another really important part about the rates is that the quantities compared are measured in the same unit. So we compared insured to uninsured people. We compared soda cans to bottle of water, so drinks. So they were all the same. That is not true with the rates. So if you are not comparing the different quantities of different units, you are going to compare, you're going to be using rates. So ratios only with the same units, and the rates are with units that are not the same, not different units. So rate is usually written as a fraction, just like you have done with the ratios. And then unit rate is a rate with a denominator of 1, and the unit price is a special type of unit rate that gives the price of one item. To calculate the unit rate to unit price, divide numerator by denominator. Once you have that number, put it over 1. Okay, so not a lot of new rules. Pretty much like we were going to be writing those rates as we were writing ratios. And then if we need to find the unit rate to unit price, we're going to carry out our division and put the over denominator of 1, the answer. Put the answer over denominator of 1. So here's our example number 4. Write each of the following rates as unit rates. So the ground dropped 74.4 feet in 24 hours in the famous Winter Park sinkhole of 1981. So our rate is 74.4. Notice here you have the feet into 24 hours. All right, 2 different units. All right. So, and that is all that we need to do here. Now, in order for us to simplify that, we're not going to simplify that. It's not us to reduce the fraction. So we're gonna leave it as it is. This is your rate. Okay. The jockey, David Gold, had 7,396 wins in 43 years of riding. Okay. So we have 7,396 into 43 years. That is all that we need to do with this rate. Okay. Part C, One Weight Watchers group lost 123 pounds for its 11 members. 123 over 11. Let me just double check that is. No, we need to write it as unit rates. So let's go ahead and backtrack that. So because we need to write it. So first we're going to set up the rate and then write it as a unit rate. I knew something was wrong with this. Okay, so part A, we found our rate. And to find the unit rate, you have to divide 74.4 by 24. 74.4 divided by 24, you are going to have, so as a unit rate, is going to be 3.1 foot per 1 hour. Okay, so once you divide by 24 hours, you will find how much it dropped per hour. So that is the unit rate. You can also write the unit rate as 3.1 feet per hour. Okay, so those are your answers. Okay, so let's go back to part B. We set up our rate, 73.96 over 43. So we just need to go ahead and divide 73.96 divided by 43. You have 172 wins per year. So unit rate, 73.96 divided by 43 gives you 172 wins per year. Because when we set it up, he had 7396 wins in 43 years. So that is going to be your unit rate. So 172 wins per year. Okay. So back to our Weight Watchers, 123 pounds, 11 members. Let's go ahead and use people for that. So now we're going to do the unit rate. So 123 divided by 11, it's going to be 11.2 pounds. 11.2 pounds per person. Okay, so that's your rate, and then convert that to a unit rate. Okay, so the part D is problem with that's looking for the unit price. So 4 chairs cost 221. So that's 4 chairs. So we have 221 for 4 chairs. All right. So on the unit price, put the total up on top. So you can then when you divide, you will divide it per chair. So then the unit price is 221 divided by 4. You have $55.25. All right, per chair. That's the unit price. You really don't need to write per chair because that you already know. That's 1 chair costs $55.25. Okay, so the last couple of problems, we are going to find which is a better deal. For each of the following, choose the better deal. So you have 10 bag of potting soil for $2.99 or 30-pound bag of potting soil for $8.97. So you would have to find the unit price and then compare which is a better deal based on your unit price. All right, so here we go. We'll have 10 pounds here. So it's $2.99 over 10. So, and then we have 897 over 30 pounds. All right, has to be set up exactly right. So if you start with exactly the same, if you start with the price on top, which that's what you should do when you calculate the unit price, you start with the price and then you do the units on the bottom. So 299 divided by 10 would give you 0.299. Right? 897 divided by 30 is going to be 0.299. So what's the better deal? None of them, they're all the same. Same unit price. Just depends on how much of the potting soil you need. But these deals are exactly the same. So we have part B. We have a package of 400 napkins for $5.95 or a package of 100 napkins for $1.95. So let's figure out the price per napkin at the 400 napkin package, $5.95 over 400, and then versus $1.95 over 100. Okay, so $5.95 divided by 400, it's going to give you 0.015. I'm going to use 3 decimal points. And then 1.95 divided by 100. You should not have to use the calculator for that, but so 0.019. All right. So the package of 400 napkins cost less per napkin than the package of 100. So 0.015, 0.019. So, and what is the better deal? Right here. Right. And here's the last one. All right, tuna fish come in 3 different cans, size cans. We have a 2-pack of 4.5 ounces cans for a 3.61, 361. We have one 12-ounce can of tuna for $2 and a 3-pack of 3.3 ounces cans for $3.19. So because we're dealing with different sizes, we need to figure out how many ounces every time you're buying. If you're buying 2 packs, how many total ounces of tuna you're buying, and so forth. So we're going to have 3 comparisons here. So 2-pack, 1-pack, and 3-pack. All right. So in 2-pack we have 4.5 times 2, we have 9 ounces, and they cost $3.61. So we have our 2 numbers. So we have 3.61 over 9 ounces. Okay. In 1-pack we have 12 ounces, so we don't need to multiply anything, and that cost $2. $2. So we have 2 over 12. And in the 3-pack, so we have 3.3 ounces times 3. So the total is going to be 9.9 ounces. They cost $3.19. So we have $3.19 divided by 9.9 ounces. So we had to make it, in order for us to compare unit prices, we had to make those unit prices over 1 unit of something. We couldn't do the cans because we had two cans, 1 can, and the cans were all different sizes, so we went for ounces. So let's do the first one, 3.61, and that one we are dividing by 9. So that comes to 40 cents per ounce. So 0.40. 2 divided by 12, that gives you about 17 cents per ounce. And 319 divided by 9.9 is giving us 32 cents per ounce. So these are our three numbers that we're comparing. And looks to me that the buying 12-ounce can for $2 is the better deal if you can eat 12 ounces of tuna in one sitting without getting it spoiled, but this is the better deal. Money-wise, that's a better deal. All right, this concludes our lesson, and thank you for watching.